We have to go back one slide, so hold on. All right, we're going to learn about volume, and we're going to determine volume for rectangular prisms and cylinders. And they can be concrete objects like boxes, cans. They could be diagrams like nets, and they can be formulas. Right here, you have a formula sheet that gives you the formula for the area of a triangle, perimeter and area of a square, perimeter and area of a rectangle, circumference, which is just like perimeter, two ways, one with radius, one with diameter, and the area of a circle. On that second row there, we have volume for our rectangular prism, which is just a box. It's like a box. And surface area for a rectangular prism. Next to that, we have the volume of a cylinder, which is a can, and surface area for that cylinder. They're telling you when you need to use pi to use 3.14 or 22 divided by 7. We can find the volume of a rectangular prism and a cylinder, which is just a circular prism, using their formulas. And the formula for the prism is length times width times height, or capital B times H, where capital B just stands in for the length times width part, times its height. With a cylinder, the volume is pi times r squared times h, or you can use volume equals B times H, where that capital B just stands in for the pi times r squared part. It's the base, it's the bottom. The difference between area and volume. Area is measured in units squared. That's the little 2. That's a flat piece, so it's just like a piece of paper. Just one piece of paper laying on a table or a desk. So how many squares will fit into that flat space? Well, in that one, they're telling you the square has 25 units squared. Volume is measured in units cubed. That's the little 3. So how many cubes will fit into a solid object? So it's like you're stacking the paper. So this cube has a volume of 125 units. So it's like you stacked 1, 2, 3, 4, 5 sheets of paper. The net of a cylinder has one rectangular curved surface and 2 circles. So if you unfold that curved surface, it looks like a rectangle, and it is the height of your tin can or your cylinder, and it is the circumference of a circle because it would go around that top or bottom part, and that's the circumference of a circle. Let's go back and recall some circle parts. You've got the circumference again, which goes around. It's showing you there around the circle. Diameter goes through the center from one side to the other side. Radius goes from the center to an outside edge. Now, a radius is half the diameter, or it's the diameter divided by 2, which is the same thing as half of the diameter. A diameter is equal to 2 radius, 2 r's. All right, so a cylinder is made of a rectangle and 2 circles. If you look at the picture, it's showing you it's stacking units, it's stacking layers. So where's the formula come from? Well, if you look at what we have to stack a circle. And the area of a circle is pi r squared. That's where that capital B is used. And that's where the pi r squared is used if you use the other formula. So if we fill a cylinder to its height, we get the formula. We take its base and we're multiplying it by its height. So it's like you've got one sheet of paper and you're stacking 7 or 8 more. A rectangular prism and a cube are very similar. In fact, you can find the volume by using the same formula for both, length times width times height. And they have 6 rectangular parts. All right, a rectangular prism and a cube are made of rectangles. So remember, square is just a special rectangle. We learned that from classifying quadrilaterals. So where's the formula come from? Well, when you look at the stack of cards or paper, there are layers of individual cards. It would be layers of individual paper. And If you stack them high enough, it looks like a rectangular prism. So volume is the amount inside, so it's the stacks. How much the stacks make. So if you take each base, which is the area of your rectangle, length times width, and you go account for how much you're going up, your height, we get our formula, length times width times height, or that capital B times H. I like to use this for missing parts sometimes. Actually, I prefer the length times width times height, but some people will show you using a capital B. Now, the example of finding prism volume. So they ask you what's the volume of the rectangular prism, and they give you measures of 10, 8, and 2. So the formula is length times width times height. So we wanted to find the variables. Well, the length is 10 meters, the width is 8 meters, and the height is 2 meters. And it really doesn't matter which one we plug the number into, but we have to make sure that we're accounting for all of them. Then you just plug into the formula numbers for the variable. Kind of like where we substituted numbers when they told us the variable like x was 3. Same difference. So we're doing volume is equal to 10 times 8 times 2. When we do the math, we're going to get the volume is equal to 160 meters cubed. The 3 there. We use m cubed since we multiply 3 measures, 3 measurements. An example of the prism volume. All right, what's closest to the volume of the cylinder? You have 2.5 inches for the diameter and 4 inches for the height. Well, the formula is volume is equal to pi r squared times h. Well, we got to define the variables. So pi is 3.14. My height's 4. However, my radius is going to be equivalent to 2.5 divided by 2 because they gave me diameter. So I have to plug into the formula numbers for their variables. So my volume is going to equal 3.14 times 1.25, which is what you get when you divide your radius up, the diameter for your radius, times 4, which gives us 15.7 inches cubed. And again, we use cubed inches since we're multiplying 3 measures. Please be careful. The biggest mistake students make is they don't calculate radius when given diameter, and they forget to square it. You got to remember to do that squared part on your calculator. Well, sometimes they want you to find a missing part in volume. So this is what you're going to do if it's a cylinder. Now, in a cylinder, it's easier to use that capital BH thing. So in this problem, they want to know the area of the base of a cylinder is 706.5 square feet. The volume is 9,891 cubic feet. How tall is the cylinder? Well, we define our variables. We know the base, because they told us, is 706.5. We don't know the height because that's in the question. How tall is the cylinder? Tall is for height. They tell us the volume is 9,891. They use the word volume. So we plug into the formula numbers, their variable, and solve it like we learned from one-step equations. So our one-step equation here is 9,891 is equal to 706.5 times h. Divide both sides by 706.5 to get our h. That gives us 14 feet. Next, they want you to find the missing part if you got a rectangular prism. So our question reads, a rectangular prism has a height of 10 centimeters and a width of 3 centimeters. If the total volume measures 90 centimeters cubed, what's the length of this shape? To me, it's easier to use the regular formula and ignore that capital B times H formula. So we have to define our variables. Well, we don't know L because it was in the question, what is the length? We do know volume. They told us it's 90 centimeters cubed. We know width is 3 centimeters and height is 10 centimeters. So we need to plug into the formula numbers for their variable and solve it like we learned from one-step equations again. So 90 is going to equal to length times 3 times 10. That gets us to 90 is equal to 30 length. 3 times 10 is 30. Divide both sides by 30 and we get L. So 3 centimeters is our L. If you need additional resources on volume, you can go to your workbook, pages Virginia 41 through 48. That's located in the back. You can find the volume of a rectangular prism example, determining the missing height, length, or width of a rectangular prism, the volume of a cylinder, how to find a missing part for a cylinder on these YouTube videos.